Let's take a look now at how we handle age problems when all we really have to go on is the sum of their ages in the present. Let's say that we knew two numbers added up to 8. Well, if one of them is 3, you can easily figure out the other one is 5. If one of them was 1, the other one would have to be 7. If the other one was 6, the other one would have to be 2. Heck, even if it was a decimal, if one of them was 1.4, the other would have to be 6.6. And if you notice, we're always doing the same thing here. If our first number is x, our other is always what we get when we take x and subtract it out of 8. So if we have x, then 8 minus x would be our other number. Now, this results in a pattern that can be hard to see unless it's pointed out to you, but once you practice a little bit, you'll be surprised at how easy it is. When we have the sum now, for the first box we use x, and for the second box we use whatever our total is, minus x. So for example 1 down here, it says the sum of the ages of a man and the son is 82 years. How old is each if 11 years ago the man was twice his son's age? So let's begin by making our table. So we're looking at the man and his son. And we're looking now, and we'll be looking 11 years into the past. So you may want to put minus 11 up here so you don't forget. So we know their ages add up to 82. So if the man's age is x, the son's age would be 82 minus x. 11 years ago, this would be x minus 11, and this expression would be 82 minus x minus 11. So here, when you combine like terms, you're going to do 82 minus 11, which is 71. So we'll have 71 minus x. And now it says the man was twice his son's age. So again, it helps if you think this next part out in plain English. The man, his age is represented as x minus 11. Was is a copula, that is equals twice his son's age. Twice, of course, means 2 times the son's age is 71 minus x. And now we've really done the hardest part of this, setting up the equation. It should be clear sailing from here. Now we'll just distribute. We get 142 minus 2x. Then we'll combine the x's. The easiest way to do that is to simply add 2x. We'll get 3x minus 11 is 142. Now to finish this off, I'll add 11 to both sides. We get that 3x is equal to 153. And we finish this by dividing by 3. And we see that x has to be 51. Again, it's a very good idea to fill in the entire table. We know the man's age is 51. 82 minus 51 is 31. 11 years ago, the man would have been 40, and the son would have been 20, and sure enough, the man was twice his son's age. Now let's take a look at example 2. The sum of the ages of a woman and her daughter is 38 years. How old is each if the woman will be triple her daughter's age in 9 years? Again, we'll begin with a table. Same idea as before. Now we're looking at a woman and her daughter. And again, we're looking at the present time, and now we're looking 9 years into the future. If the woman's age is x, her daughter's age has to be 38 minus x because their ages add up to 38. Again, we just add 9 to both of those. Here I'll have x plus 9. For the daughter, I'll have 38 minus x plus 9. Well, 38 plus 9 is 47, so this is just 47 minus x. There we are. And now we do the same thing as before. Now we're saying that the woman's age will be triple her daughter's age. So the woman's age is given as x plus 9 will be, still equals, triple 47 minus x. And again, we just do our usual algebra and we're all set. So I'll begin with the distributive property. X plus 9 equals 141 minus 3x. Same idea as before. I'll just add 3x to both sides. And I'll subtract 9 from both sides here. I will get 4x equals 132. I simply divide both sides by 4. And I get here that x equals 33. The woman's age is 33. Her daughter's age is 38 minus 33, which is 5. 9 years from now, the woman will be 42 years old, and the daughter will be 14 years old. And that's it. But again, with age problems, it's very important to make sure you actually answer the question. For the first problem, they ask us how old is each? So our answers are 51 and 31. For example 2, again, they ask us how old is each? So our answers are 33 and 5.